Today's presentation, I'm going to be talking about a range finder, and in particular I'm going to be talking about the range finder part number HCSR04. So the range finder is part of our layer 3 architecture, and I've put in a marker on the items from layer 2 that we're going to have to use to program this range finder in our microcontroller. So we're going to need the UART, IO ports, and timers. So the agenda for today, I'm going to be talking about the Ultrasonic Rage Finder HCSR04, give you background with respect to that range finder. Next, I'm going to go through some of the calculations that the microprocessor has to do with the data obtained from the range finder. Then we'll go through a sample program that puts all that together. So this is what the range finder looks like. So it sends a signal, a radio signal, and then it waits till it hits something and gets back, and then it provides the time it took for the signal from the time it goes from the transmitter to the time it got back to the transmitter, which is the receiver. So the ultrasound module HCSR04 emits a high frequency sound wave at 40 kilohertz. The sound wave travels through the air. If it finds an object, it bounces back toward the ultrasound module. The ultrasound module receives the reflected sound, and by measuring the time it took for the signal to travel to and from the object, we can calculate distance. The range is between 2 centimeters to 400 centimeters. It basically detects any object between 2 centimeters and 4 meters. Sorry. So let's look at the program where everything is going to come together. So to make this work for the ultrasonic range to send a signal and wait for it to come back and provide information, we need to send a 10 microseconds high pulse through the trigger pin to initiate ultrasonic burst. So first thing we do is through pin D7, in this case, we send a pulse 10 microseconds. Next, after the trigger pulse, we monitor the echo pin. This pin goes high for a period of time which will be equal to the time taken for the wave to return back to the sensor. So basically what happens is, when we put out the trigger signal, a signal would go high as soon as the ultrasonic rangefinder sends out its radio signal. And when this signal gets back to the finder, the rangefinder will it goes low. So it goes high as soon as it sends the signal. It remains high until it gets the signal back. So if we figure out the time from the time the signal went high till it gets low, if we figure out how long it took, then we'll know how far things are. The moment the echo pin goes high, capture the current time value. So what we're going to do is we send our echo, then we wait until the echo goes high. As soon as the echo goes high, we're going to use the input capture capability of the microprocessor to capture the timer value. Next, the moment the echo pin, that's echo pin, goes low, capture the current timer value. So we capture the time when the signal goes high, and then we capture the time when the signal goes low. Calculate the pulse duration. The pulse duration is the difference between the final time and the initial time. Calculate the distance. The distance is going to be the speed of sound, and that's how fast the sound wave that was emitted is traveling. And then times the pulse duration, but that has to be divided by 2 because the pulse duration is going and coming back. So we only want the coming back portion. So we have velocity times gives you distance. Send data via UART. Display the measurement distance on your computer by sending the data over the UART. So we put an object here. We figure out how far it is, and then we report it to the laptop. Okay, calculations we have to make this happen. So as I noticed, we have speed of time. So we have the speed of sound, the speed times the time it took to go and come back divided by 2. Now the speed of sound is 343 meters per second. That's centimeters, 34,300 centimeters per second. Now the input we get from the timers are going to be in ticks, not seconds. So to convert those ticks to seconds, we have to multiply the ticks per second of our clock divided by the signal returns in ticks, which is what we get from the timer. So what it amounts to is distance is equal to 34,300 speed of sound times the time divided by 2. Now, if we use timer, we need to figure out scalars. Okay, so time is distance divided by the speed. Now, we know that the maximum distance, so I want to figure out if I need to use a scalar, whether my numbers are going to fit in the 16-bit register. So let's figure out how big the time can be. So I have 16 million ticks per second times 400 centimeters, which is the maximum distance that this can travel. And of course that maximum distance is divided by the speed of sound. And that maximum distance is going to give me the largest time this can take. So that would give me a maximum of 186,588 ticks. But that's just for one way. So we're going to need to place a 300,773 177.8 ticks. That's how big the number can be. So let's figure out what's our pre-scalar. So as usual, we take the number divided by the maximum number. It holds a 16-bit register, and that gives us 5.6 but we know that prescaler can be 1, 8, 64, 256 or 1024. So obviously we select the closest, which is going to be 8. Okay, so let's look at our sample program. So I'll start by giving you a high level of the program, and then I will go back and talk about the details. So we have a routine called init ports, which is going to be responsible for initializing the ports to inputs and outputs. Next we have init timer 1. This routine is going to be responsible for setting up prescalers and also getting everything set up for the first input capture. Next, we have a routine called trigger measurement, which what it does, it sends a signal to the range finder, so it does a measurement. Next, we have the main program where we initialize all that needs to be initialized, and then we're going to start sending the trigger signals, reading how long it takes to go and come back, performing operations to calculate a distance, and then displaying those distance in the laptop via the UART. So let's get into the details. The init ports. These line codes, what it does, it sets the port PD7 to output, and it sets the port PB0 to input. Next, we have the init timer. So here what we do is we clear the input capture flag, so things start working, I should say. Next, we set up with these 3 lines of code the prescaler to 8, and finally we set the system so it starts capturing on a rising edge, and set the timer to 0. That's just good practice. Next, we have the trigger measurement. For the rangefinder to start working and sending signals, what we need to do, we need to send a trigger signal, which is the signal goes high for 10 microseconds and then it goes low. After the rangefinder gets that signal, immediately it starts doing its first range finding, we should say. So let's look at the main. So we have init ports. As I mentioned, it sets your ports to inputs and outputs. That would be your trigger and your echo. Next we have the init UART, which is going to enable us to send items to the B display in the laptop. Next we have init timer 1, which is going to allow us to get input capture signals. Then we have, first thing we do here is we send a hello world to the laptop, just as a heartbeat to let it know that yeah, we are alive and we're ready to go. Then we have a new line, so it looks pretty. So let's get into the while loop. So the while loop, first thing we do is we have to set up, we want to reach a signal with rising edge. So it goes from low to high. Next, we clear the flag so the input capturing gets started, followed by we trigger the signal. That means that the rangefinder is going to start sending its signals. We set the timer to 0, and then we just sit there and wait until the rangefinder sends us a signal that should be a rising edge. So when that happens, we immediately capture the counter. That's the time when the signal was sent. Now we want to wait for the signal to come back. So we do that by setting up before we do that, we reset and clear the flag so things start moving again. Next, as I was saying, we need to know when the signal came back, and that's going to be when we get a trigger which is caused by the signal going from high to low. So that's what we're doing here. It's telling the microcontroller when the signal goes from high to low, I want to be able to capture that time. So here we get into the while and we just wait until the signal goes from high to low. As soon as that happens, what we do is we capture the counter, which gives us the final time. Now we have the initial time, we have the final time, and what we want to do is we want to display in the laptop the distance of the object. So we send the word distance first. So that gets displayed on the laptop. Next, we calculate the total time in ticks, which I have already explained how we do that, and then I convert those ticks to seconds. And finally, I calculate distance using the time, which is divided by 2, as I explained before, multiplied by the speed of sound. That gives us the distance of the object. And then I display that in the laptop. And then I write centimeters and putting a delay of 1000 milliseconds, and then I do that over and over and over. So that way I can capture the distance as an object is getting closer or getting away. Okay, so this shows you the output. So what I had here was different objects at known distance, and it worked fairly well. I also like to note that when I use the while loops, I can also, instead of the while loops, I could use interrupts. So that gets us to the summary. So today we talked about the Ultrasonic Rage Finder, HCSR04, gave you some background. I showed you what calculations you need to do based on the data you get from the rangefinder. And finally, we went through a sample program. So I hope you've enjoyed this presentation, and thank you very much for taking the time, spend that time with me. Thank you.